Let's start today with lesson 6, which is talking about angle identities. In this lesson, we are going to see how can we use the summation and the difference identities. Now, some of the angles or some of the trigonometric ratios written in a single angle and some of them written in two angles. Like sometimes you will see like you have an sine of 30 and sometimes you see like sine of 30 plus 50 as an example. So it can be written in single angle or in two angles. Let's talk today about how can be written in single angle and what are the identities of them, and how can be written in two angles and what are the identities of them. Let's start now here with the first one. The first one of the first identities that are the negative angle identities. That sine, if you want to find sine of negative 30, it will be negative sine of 30 degrees. As an example, all of us know that sine of 30 is half. So if you want now to find sine of negative 30, remember that sine of negative 30 will be negative sine of 30. And sine of 30, we know that it is half times negative. So that means sine of negative 30. If you try it, or if you find by calculator, you will find it's negative half. So the first identity, that sine of negative theta will be negative sine of theta. That means you can say, you can drop out the negative sign.
But sometimes, like the calculator, it's like the model answer will be not negative, it will be positive.
For the negative of
like
the angle?
Yeah, like sometimes when you write sine negative 40, they bring it as like positive.
No, it's supposed to be negative. That means there's something wrong.
Okay, teacher.
So here, if you have sine of negative 20 as an example, it will be negative sine of 20. So like you drop out the negative sign, so it comes like negative sine of 20. This is here for the sine. Now what about the cosine? For the cosine, you will see that the cosine of any negative angle will be the same of the cosine of its positive. Like cosine of negative 30 will be the same as cosine of 30. Cosine.
Oh, it was cosine, teacher.
It will be cosine of 50. So for the sine of negative theta, it will be negative sine of theta. So you will drop out, or you take out the sine, but for the cosine, you will cancel. They like it's cancel it. The cosine for negative will be the same as the cosine for the positive. And the same for tan. The tan is like the sine, that the tan of any negative angle will be the negative of tan of the angle. So as an example now, if you have, or if you know that sine of 45, we know that it's 1 over square root of 2. And cosine of 45, we know that it's 1 over square root of 2. And tan of 45, it's 1. if you know now these three angles, and I asked you about now sine of negative 45. Hello, once you see sine inside a sine, a negative sign, remember the negative angle identities, that the sine of negative 45 will be negative sine of 45, which is negative 1 over square root of 2. Right. If I ask you now, so my three questions are: find sine of negative 45, cosine of negative 45, and tan of negative 45. The first part, we found it that sine of negative 45 will be negative
over root of 2
of 45, which is negative 1 over square root of 2. The second one now. Cosine of negative 45. The cosine of any negative theta will be the same of the cosine of the positive. So will be the same as 1 over square root of 2. And the last one, tan of negative 45, it's negative tan of 45. What is the tan of 45? It's 1 times negative, so it's negative 1. So the tan of negative 45 will be negative 1. Is it clear?
Yes.
Yes.
Yes, teacher.
Teacher, is it because sine and tan are odd functions?
Yeah. That's what we talk about them in calculus. Not now. But that's because they are odd and even. Now, let's talk about now cofunction identities. If you remember, when I told you before that sine of 30, I told you like it's cosine of 60. And cosine of 30 is the same as sine of 60. And tan of 30 will be cotan of 60. But why? Why can't I say that like this? Or why can I say like sine of 15 is like the cosine of 85? Did you remember when when we find the complementary angles, we say that the complementary angles, that they are two angles, have the same, remember the word? Like complementary angles, that their summation is 90. Okay, if two angles that their summation is 90, so the cosine of the first angle will be equal the sine of the second angle, or the sine of the first angle will be equal the cosine of the second angle, or the cotan and tan. That's why here 30 and 60, if you add them, they are complementary. 85 and 15, if you add them, you get 90. So if you want now to find sine of 20, you will say that sine of 20 will be cosine of 90 minus 20, which is 70. So sine of 20 equal to cosine of 70. So these are, we call them cofunction identities, like the sine of pi over 2 minus theta will be cosine of theta. like sine of pi over 2 minus pi over 4 would be the same as cosine of pi over 4. Did you remember when we have cosine
Yeah.
45 equals sine of 45? Why they are equal? Why they are 1 over square root of 2 to the both sides? Because if you add 45 plus 45, you get 90. So they are complementary angles.
طب teacher, is there a supplementary angle like 180?
Now, they're only complementary.
Okay.
If they are
Is this why wait, is this why sine is called, like cosine is called the complementary of sine? Cosine. Wow, I just realized this.
maybe,
And tan, cotan.
maybe, yes,
Complementary of tan.
maybe. Like after you, if it's true, you can say it's like theorem of Simpson. So the cosine here is an the sine of any angle of the sine of, as an example, 10 will be the cosine of 80. And cosine of 10 will be sine of 80. Why? Because 80 and 10 are, if you add them, they are complementary angles. I think something they are true, yeah. And see sine, just a second, please. Sine and complementary of sine and cosine. Tan and complementary of tan is cotan. And secant, complementary of secant is cosecant, or write it as like this. Maybe yes.
Yeah, it would make sense.
Yeah. Now, so the cofunction identities and the negative identities for the single identity. Now, let's see here, how can we find the cosine or sine of two angles that they are added? Like, if you have to find sine of 45 minus 15 as an example. You cannot say that, you cannot distribute the sign. You cannot say it's like sine 45 minus sine of 15. No, there's a formula for it. Let's see now what are the identities for how to find the sine of angle difference, the cosine of angle difference, and the tan for the angle difference. Let's start with the first one. If you have two angles that they are subtracted, sine of A minus B will be, you start with sine of A and you will end with sine of B. Then, since we have minus sign, we keep the minus sign between them. And then you will write, since we have sine of A, so we write cosine of B. The opposite of sine is cosine, and the opposite of A is B. And for the sine of B, the opposite of sine is cosine, and the opposite of B is A. So the formula of sine A minus B is sine A cosine B minus cosine A sine B. And they have a minus sign. We keep it here as a minus sign. Now, let's talk about the cosine. For the cosine here now, you will write the cosine for the first two angles like cosine A, cosine B, and then the sine of the two angles, sine A, sine B. And remember that, as we said before in the negative identities, the cosine and sine, they are opposite to each other. So if the sine here, or if the angle difference of the sine keep the minus as it is, but the cosine will not. If we have here an angle difference, you must put a plus sign between these two statements here. So for the sine, if you have a minus sign, you will keep the minus. But for the cosine, if you have a minus, you will make it a plus. Then sine of A minus B, I will repeat, they will start, you must start with sine of A and end with sine of B. And between them, put the cosines. In the cosine, no, start with the cosines, end with sine. These we call them angle difference identities. Now, what about the tan? The formula of the tan will be tan of A minus, here for the tan, you keep the minus sign, tan of B over 1 plus tan of A tan of B. So here they will be positive, and up they will be negative. Since we have an angle difference, keep the minus sign as it is. So remember, in the previous identities here, as you remember, we said that for the sine and the tan, they are the same. We keep the minus sign. And for the angle difference identity, sine and the tan, they are the same. We keep the minus sign. But for the cosine, you will cancel it. So if you have here a minus sign for two angles in cosine, you will cancel it. So you make them plus. But for the sine and tan, you will keep the minus sign. So you keep them here as minus here and minus here. So let's remember what are the identities. Sine of A minus B is sine A cosine B minus cosine A sine B. Cosine of A minus B is cosine A cosine B plus sine A sine B. And tan of A minus B will be tan A minus tan B over 1 plus tan A tan B. Let's now have an example. Now, how the questions will be. The questions for the angle difference identities come like this. What is the exact value of cosine of 15? Now, some of you teacher, I can count by calculator. Yeah, by calculator, you give me the answer as a decimals, like as an example. But at the exam, if you have the answers like this,
Teacher, we can make it also in the calculator.
so how you will find the
What
answer?
if the calculator is prohibited in the exam?
Yeah.
So how they will be? So how they will be here? Here you have 3 choices. So you want to choose now which one is the correct answer. Sometimes if you become like an essay, you will tell me, or you must write the answer as an essay. You will tell me the formula. Some of them I will bring you the statements and you want to guess which angles that I'm talking about. Like the extra examples you will solve it inshallah today. Let's start here now with cosine of 15. How did you find now cosine of 15? By an angle difference. And the first step, you have to think that like, give me two main angles that if you subtract them, you get 15. How can I know? Let's come back now here to this table. Here now, find two angles that if you subtract them, you get 15.
45 and 30.
45 and 30, 60 and 45. So we can solve it like 45 minus 30 or 60 minus 45. So let's say like, 30 minus 15. So this is the first step now. I wrote it as cosine of A minus B. Then, let's now rewrite the formula. Remember that of cosine of A minus B, it will be cosine of A, cosine of B, and the cosine cancel the minus. So plus sine of A, sine of B. Then you will write them like cosine of 30, cosine of 15. And what did I do here? I'm sorry. They are 45 minus 30. Sorry. Because I must search about two angles that I know their sine and cosine. So cosine of 45, cosine of 30, sine of 45, sine of 30. Then cosine of 45. Now what is the cosine of 45? It's 1 over 2 times cosine of 30 square root of 3.
Or 2.
Half, sorry. Cosine of 30, square root of 3 over 2. Plus sine of 45, it's 1 over square root of 2. And sine of 30, it's 1 over 2. So after I replace here, you will find that it's square root of 3 over 2 square root of 2 plus 1 over 2 square root of 2. Since we have the same denominator, so we'll find the answer as square root of 3 plus 1 over 2 square root of 2. So here, if you want now to find the exact value of cosine of 15, you will find them like, first, you have to search about two angles that if you subtract them, you get 15. Some of you want 45 minus 30. Now, by the way, if you choose 60 minus 45, you will get the same answer. Then after I choose these two angles here, I will write the formula. Like cosine of 45, cosine of 30, plus sine of 45, sine of 30. Then you will evaluate the angles and evaluate the answer. Sorry, Rose?
Teacher, we need to use the angles of the table that we used to solve, right?
Yes, the main angles. Yeah.
Okay.
Is it clear?
Yes, teacher.
Yes.
Now here, sine of 15. Now, sine of 15, remember that I can say that sine of 15 will be sine of 60 minus 45 as an example. Hella, do you know why I choose these two angles?
Yeah, because it will be equal 15.
Yeah, because if you subtract 60 minus 45, you will get 50. Then you will write the formula. Now, sine of two angles that they are subtracted will be sine of the first angle. You keep the minus sign, sine of the second angle. Then you will write the opposite of sine is cosine of 35. And here you will write cosine of 60. Then sine of 60, square root of 3 over 2. Sine of 45 is 1 over square root of 2. Minus cosine of 60, which is half, times sine of 45, which is 1 over square root of 2. So you will find that it is square root of 3 over 2 square root of 2 minus 1 over 2 square root of 2. And you will get the answer like square root of 3 minus 1 over 2 square root of 2. Is it clear?
Yes, teacher, thank you.
Yeah. So teacher, for the sign, it will be minus, right? Is this thing
Yeah.
but minus?
Sine with tan, you will keep them minus. But the cosine, you will change the sign.
Oh, yeah. Okay.
Now, I want you now, using this table here, to find cosine of 135. Yeah, I give you now 3 minutes. Please try to solve, or how to try to find here cosine of 135.
Okay, teacher.
Teacher, can you repeat what you just said?
Cosine 135.
Okay.
Do we have to say the answer or send it on the chat?
I'll send it on the chat.